Everyone, welcome back to premium course still Warehouse Design. After we complete analysis and design and fit the raster and column, we use method to fit column by edit property. So now I will show you another method to correct restraint on column by using method Set Restraints. Okay, click on Show Alter Stage and scroll down to the restraints and change the entity types to columns and review. Now check the lateral type, restraint type, lateral. This is the color phase A and phase A and phase C. You can check more detail and support document about which one is the phase A and phase C. Yes, for A, you show the direction of beam. This is the phase A, and opposite flank is the phase C. Yeah. How you know about phase A and phase C? By show the direction of beam. Now let me come back to Tekla Structural Designer. Yeah, this is the direction of the columns. So the outside flank is the phase A. Okay. Now you can set the restraint. You change it to set, and the restraint type, change it to the restraint, and restraint. Click on the phase A and select the restraint in the girths intersect with the columns. Yeah, in the position, select it, and in the position, select it to set. And for the right column, also the same. Phase A, yeah, phase A, change it. Okay, and again change phase A to phase A and phase C and select for the location because we want to add restraint. Okay, select and select. Change the restraint to strut and change the restraint type to measure and minor. And set restraint at the location. Okay. How you can correct the restraint in column by using the set method. For more detail, you can read my support documents on the section columns. Lateral torsional buckling restraint on columns. For column design using the Eurocode, the LTB design length is assumed to be between those positions where the column is restrained in both the measure and minor compression buckling direction at plane A and C. So why we had to add restraint on the measure and minor C? Because we want to add the lateral torsional restraint on the column. Yes, LTB. We add the restraint in both measure and minor compression buckling direction and at the plane A and C. It's if we call the interaction questions given in the Eurocode only cover the design between point of full restraint in both directions. It is a very important note in Tekla Structural Designer. Again, come back and click on design. Click on design or static to run analysis and design again. Yes. Now let me check why it failed. Maybe because we change the direction of the top and bottom. Now we had to correct it by using view and author restraint, change it to the beam. Okay, it's correct right now. Let's draw. Yes. Now we have to set it again by clicking on this intersection point. We add the torsional restraint on the bottom of the beam. Okay, save it. Come back to design, analysis and design static. Seal the models and check. Yeah, it passed. Now check at the middle column by right click and check static and check for the lateral torsional buckling. The length LTB is equal to 1.5 meter. So we had to add the lateral torsional restraint at the intersection the purlin with the bottom plane of the column. I will show you later about how we can add the restraint to the purlin and to the column. Use the same. The best location to add restraint, we add at the top, at the maximum bending moment, and for the column also we add the torsional restraint at the tension phase. Okay, tension phase of the member. So for this raster at the intersection with the column, the maximum tension moment at the top, so you must add restraint to connect from the purlin into the bottom of the flank, and other side we do the same to add restraint at the compression plane. For the location in the compression plane, it's no matter to add the torsional restraint, but other side for the tension plane we must to add it again. You can check it in the analysis result for more detail. For the measure and change it to the local envelope. Yes, this is the way you know how to add restraint on the beam and on the column by checking the envelope force moment. This tension force, the tension moment, tension phase at the top of the flank, and this one tension at the bottom of the flank. So the top flank in compression. In compression, we can add the restraint, torsional restraint in the location, and for the location you can add at the intersection. It's a noise, but in my design code I add it all intersection of the purlin with the raster. For the column it's the same. We add it the maximum moment in the location and in the location, so you can add torsional restraint. It's a noise for the location. Location you can add or not, it depends on you to verify and check it. And for the raster it's the same. I show in support document how you can add restraint on the side rail or on the purlin. We use the same concept on the column and raster. Connect from the purlin or side rail into the bottom plane to prevent the lateral buckling of column and all the beams. And this is the this beam we connect from the top of column to top of column each other to make stability of the out of plane or frame. And this is the location, the best location to add the torsional restraint. We should add it in the location and in the location. And for the column, we also add at the top of the column, to prevent torsional buckling of the column and of the raster. This is the best location to apply the torsional restraint. Yes, torsional restraint in the compression plane and in the tension plane. In the tension plane, you must to add torsional restraint. Torsional restraint. And compression plane, you can check if it not required. You do not need to add the torsional restraint. But in the practice, you should add it at the end of the raster in the location. At least this is the tension plane. You should add the full restraint. The full torsional restraint. Torsional restraint. Thank you for your watching. I hope you enjoyed the tutorial. For more details, ask me in the group. Thank you.